In this video, we are going to talk everything pertaining to quadratic equations. So first, let's go ahead and define a quadratic equation. So it's an equation that contains a square of a variable, but no higher powers than that. So an example could just be x squared. Now the standard form for a quadratic equation is ax squared plus bx plus c is equal to 0. Now we need to note that that is true when a, b, and c represent real numbers and a cannot be equal to 0. Now if a were equal to 0 in the front here, x squared would not exist. It would be 0. And then we wouldn't have a quadratic equation because the definition states that we need to have a squared variable. So let's look at an example of that. An example could be 3x squared plus 7x minus 2 is equal to 0. And so our a, b, and c values would be, a would be equal to 3, b would be equal to 7, and c would be equal to negative 2. And so this quadratic equation is already in standard form. Now an example of a non-standard form would be 3x squared minus 3x squared is equal to negative 7x plus 2. That is still a quadratic equation, it is just not in this standard form. So let's go ahead and work through some examples. So we want to find all real solutions for the equation y squared is equal to 18 minus 7y. So the first step to solve for this is to write it in standard form. So we're going to subtract 18 and we're going to add 7y and move it over to the left side. So we have y squared minus 18 plus 7y. And now we need to rearrange this equation so it's in our standard form. So we have y squared plus 7y minus 18 is equal to 0. Now that we're in standard form, our next step is to factor. So y squared plus 7y minus 18 can be factored as y plus 9 times y minus 2. And since the equation is equal to 0, our final step is going to be to set the factors equal to 0 and solve. So you have y plus 9 is equal to 0, or y minus 2 is equal to 0. And if we solve for both of those, we'd be subtracting 9 and adding 2. We would have y is equal to negative 9, or y is equal to 2. And those are both of the real solutions for this equation. So let's try another one. We want to find all real solutions for the equation w squared is equal to 121. So again, the first step is to write it in standard form. All we need to do is move our 121 to the left side. Now we'd have w squared minus 121 is equal to 0. Now this is indeed in standard form. We just need to note that for our a, b, and c values, our b value is going to be 0. But it still meets the criteria for a quadratic equation because we have our variable that is squared. And so to show that, if we add a w squared, our a is 1, and bw, our b is 0, so that cancels out, and then plus our c value. So our next step is, again, to factor. So w squared minus 121 can be factored as w plus 11 times w minus 11. And then again, our third step, we're going to set the factors equal to 0 and solve. So we would have w plus 11 is equal to 0, or w minus 11 is equal to 0, which would leave us with two real solutions of negative 11 or positive 11. Let's check out another example. So we're going to find all real solutions for the equation x times x plus 2 is equal to 7. The first step, we're going to write it in standard form. So with this, we're going to first multiply out our x value here. So if we multiply that through, we would get x squared plus 2x is equal to 7. And now we're just going to subtract our 7 from our right side to move it to the left, and we would have an x squared plus 2x minus 7 is equal to 0. Now, normally, our next step would be to factor, right? But this is not factorable. And so in this case, we are going to use the quadratic formula. Now the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And now this is where knowing what our a, b, and c values come in handy. So in this equation, our a value is going to be 1, our b value is 2, and our c value is negative 7. So now all we need to do is plug these three values into our quadratic formula here. If we did that, we would have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 7 over 2 times 1. If we simplify that and simplify the inside of our square root, we would end up with negative 2 plus or minus 4 plus 28 over 2. And now if we add 4 and 28, we would end up with a square root of 32. And now we can rewrite the square root of 32 as the square root of 16 times the square root of 2. So we have negative 2 plus or minus square root of 16 times square root of 2 over 2. And now we know that the square root of 16 is 4. So let's solve for that. We would have negative 2 plus or minus 4 times the square root of 2 over 2. And now we have 2 as a common factor here. So we can pull this equation apart like this. We would have negative 2 over 2 plus or minus 4 times square root of 2 over 2. And now when you rewrite it like that, it's easy to notice where we can cancel out our 2's. So we can cancel on the left side here as well as on the right side, which would leave us with a final answer of negative 1 plus or minus 2 times square root of 2. And so our two possible answers are going to be a negative 1 plus 2 square root of 2 or a negative 1 minus 2 square root of 2. And that would be the two real solutions for this problem. Our next example, we are going to again find all real solutions for the equation 1/2 y squared is equal to 1 over 3y minus 2. So just like all the previous ones, our first step is going to write it in standard form. Now I recommend going ahead and maybe solving this one by yourself at this point, and then coming back and checking your answer. So to write it in standard form, we're going to move our 1 over 3y minus 2 over to the left side to join our 1/2 y squared. And now that we have done that, this is going to be a lot easier to solve if we can cancel out these fractions here. So how we're going to do that is we're going to multiply this whole equation by 6 on both sides. And when we do that, we're going to be canceling out the denominators of our fractions because both 2 and 3 are a factor of 6. And so when we solve for that, we would get 3y squared minus 2y plus 12 is equal to 0. Now we have it in standard form and our fractions are canceled, so this is easier to work with. Step number 2, we're going to use the quadratic formula. As a reminder, here's the quadratic formula. We have our negative b plus or minus square root of b squared minus 4ac over 2a. So with this problem, our a value is 3, our b value is negative 2, and our c value is 12. If we plug all of those values in, we would have 2 plus or minus the square root of negative 2 squared minus 4 times 3 times 12 over 2 times 3. So let's go ahead and solve our multipliers here. We would have 2 plus or minus the square root of negative 140 over 6. And now this is where it's important to know what the problem is asking for. We're looking for all real solutions. And when you have the square root of a negative number, you are not going to get a real solution. You're going to get an imaginary solution because of the imaginary unit. So in this case, there are no real solutions. And we get to stop there with this problem. So that wraps up solving quadratic equations. Thank you for watching, and please stay tuned for more educational content.